The technical analysis of industrial machinery emphasizes the severe risks associated with running nip points and mechanical entanglement. These pinch points exert frictional forces that far exceed human strength, pulling material or clothing in at operational speeds. Because entanglement occurs in milliseconds, it outpaces human reflexes, making self-extraction impossible. Personal attire like loose garments or unbuttoned sleeves acts as a dangerous catalyst, while gloves can inadvertently increase snagging risks on abrasive surfaces. This incident highlights deficiencies in engineering controls, specifically inadequate guarding and inaccessible emergency stops. To ensure safety, operators must strictly follow lockout protocols and use specialized tools for adjustments. Ultimately, combining robust mechanical safeguards with disciplined awareness is the only effective defense against the raw power of mechanical force. This technical analysis evaluates critical structural failures and industrial hazards, emphasizing the physics of high-risk environments and the necessity of rigorous safety protocols. In tilt wall construction, mechanical failures often stem from inadequate bracing, where shifting centers of gravity transform massive panels into uncontainable sources of potential energy. Similarly, performing hot work on unpurged vessels triggers instantaneous pressure expansion, creating shockwaves powerful enough to shear steel and launch high-velocity projectiles. To mitigate these risks, personnel must avoid the line of fire and recognize mechanical pinch points that close in milliseconds. Effective risk management requires strict lockout protocols, independent spotters for perimeter control, and a trained exit-only reflex to prioritize immediate evacuation over property salvage. This technical analysis evaluates the physics of motion and structural integrity in industrial settings to mitigate hazards. A primary concern is kinetic energy. In forklift crane collisions, massive curb weights generate lateral shear forces EK-1-2 that destabilize outriggers and snap anchor pins. Furthermore, uncontrolled potential energy on inclines highlights the failure of friction-based brakes, making mechanical wheel chocks an essential fail-safe. Human factors, such as entering the line of fire or attempting to manually stabilize shifting loads, prove that skeletal strength cannot compete with industrial inertia. To prevent these disasters, facilities must enforce rigid exclusion zones, implement lockout protocols, and utilize spotters to manage technical blind spots. Ultimately, technical discipline and life-first training are the only effective barriers against the cumulative lapses that lead to catastrophic failure. The technical analysis of cargo instability highlights the severe risks of overstacking and improper securement in logistics. A high center of gravity increases sway amplitude, where even minor shifts in velocity can trigger a tip over. This often results in a domino effect as compressing lower units destabilize the entire stack. When cargo falls, it acts outward, creating an expanded danger zone that catches personnel standing near the vehicle's perimeter. This incident underscores the failure of physical restraints like side stacks and T-downs, allowing inertia to displace heavy loads. To prevent such events, facilities must enforce the bar-point securing rule and train workers to recognize shadow zones where entry is prohibited. Ultimately, rigorous adherence to height limits and cargo securing protocols is a mandatory requirement for maintaining a safe workplace. This technical analysis evaluates the mechanical failures and gravitational risks involved in manual material handling, focusing on the physics of instability and hazard mitigation. A primary concern is pivot point failure. When heavy materials are tilted, insufficient friction causes the base to kick out, leading to a rapid collapse as torque exceeds equilibrium. Furthermore, large flat materials possess a sensitive center of gravity that can shift easily, causing immediate structural instability. Human factors, such as standing in the line of fire or lacking team coordination, exacerbate these risks, as gravitational acceleration often outpaces reaction times. To ensure safety, facilities must replace manual labor with machinery like forklifts, enforce strict exclusion zones, and utilize straps or chocks. Ultimately, personnel must prioritize life over property, as technical discipline is the only way to counter the inertia of multi-ton industrial materials. The technical analysis of excavator safety emphasizes the critical risks posed by blind spots and the breakdown of site communication. Excavators have significant visibility obstructions, particularly beneath the boom and bucket, where ground personnel can easily vanish from the operator's line of sight. Because hydraulic buckets move with massive inertia and force, any object in their path is swept up without resistance, while the weight of loose materials like sand creates immediate engulfment hazards. This incident highlights a failure to maintain the mandatory 6-foot danger zone and a lack of two-way confirmation before initiating work cycles. To prevent such events, workers must wear high-visibility gear, utilize designated spotters, and adhere to a strict stop-on-site rule. Ultimately, safety near heavy equipment depends on clear signaling and maintaining a safe distance, ensuring that human presence is always acknowledged by the operator. This footage captures a critical industrial incident involving a high-capacity metal press, where a worker operating near the machinery experienced a sudden equipment entanglement with life-altering consequences. Preliminary reports suggest the cause was a lapse in focus, a protocol breach or mechanical failure, serving as a sobering reminder that strict adherence to safety regulations is non-negotiable. To prevent such tragedies, workers must strictly follow all standard operating procedures and wear proper personal protective equipment like hard hats and safety glasses at all times. Maintaining high situational awareness is vital to avoid distractions near active machinery. Furthermore, regular equipment maintenance and continuous safety training are essential. Occupational safety is a collective responsibility. Stay vigilant to protect everyone. Safety first every time. This technical analysis evaluates the mechanical principles and systemic risks in industrial environments, emphasizing engineering controls and safety compliance. Industrial machinery like lathes generates extreme torque, creating mechanical traps that exceed human resistance when entanglement occurs, highlighting the need for accessible e-stops and torque sensors. Structural instability in heavy loads often stems from center of gravity shifts, where minor deviations transform static masses into free-falling potential energy, potentially triggering a domino effect through progressive collapse. Furthermore, pneumatic failures release instantaneous energy, creating shockwaves and high-velocity projectiles capable of penetrating standard barriers. Identifying the line of fire and pinch points is crucial, as any position within a load's path or aerodynamic suction zone poses a threat. Systemic risk management requires strict lockout, tagout, LOTO procedures, multi-layered safeguarding like light curtains, and independent safety spotters to monitor blind spots during complex operations. This technical analysis evaluates mechanical failures and gravitational risks in industrial operations, focusing on the physics of instability and hazard mitigation. A primary concern is kinetic energy. When forklifts impact structures, their immense mass generates lateral shear forces that destabilize outriggers and trigger structural collapse. Furthermore, dynamic loading and center of gravity displacement often push equipment past the point of no return, where gravitational acceleration outpaces any manual intervention. Human factors, such as entering the line of fire or lacking team coordination, exacerbate these risks, especially in technical blind zones. To ensure safety, facilities must prioritize mechanization over manual labor, enforce rigid exclusion zones, and utilize mechanical wheel chocks for energy isolation. Ultimately, technical discipline is the only effective barrier against the cumulative lapses that lead to catastrophic failure. The technical analysis of cargo instability highlights the extreme risks of improper unloading sequences and shifting centers of gravity. When high-stacked cargo lacks mechanical interlocking, slight vibrations can trigger a collapse. Low-friction packaging further accelerates this sliding effect as inertia overcomes friction. Workers often enter the shadow zone near the vehicle, leaving them no room to retreat when cargo falls from heights of 6–10 feet, creating massive impulse forces and compression hazards. This incident underscores a failure to use temporary barriers and a breach of the stair-step unloading rule. To ensure safety, facilities must utilize designated spotters and enforce exclusion zones. and strictly adhere to the never under a load principle. Ultimately, safety in logistics depends on controlling potential energy through proper clearances and mechanical restraints.